Hello everyone, welcome to today's lesson on compound shapes. Alright, so last time we worked with just usually one triangle, but this time we're gonna do multiple triangles and then see how we can use trigonometry in those cases. Alright, so as usual, answer to the nearest tenth. Okay, so lighthouse keeper is 300 meters above sea. Alright, so we can draw that first. So we got the sea here. We got a lighthouse. Alright, we got lighthouse keeper up there. So 300 meters above sea level. Right? And they spot two ships in the distance. Right, with the angle of depression of 4.5 and 6 degrees. Right? So we want to find out how apart the ships are. Okay, so we got two ships here. One ship's here. And second ship's here. Right? So we're looking at angle of depression here. So here's horizontal. Actually, let me do in different colors so it's easier to see. So the angle of depression for this ship and angle of depression for this ship right here. Alright, so the first one is smaller at 4.5 degrees. The second one's bigger at 6 degrees. Alright, so this is what the diagram will look like. And of course, we can draw out separate triangles. Just so it's easier to visualize. So we got a green triangle here. So the green triangle, that's 4.5, 300. I want to find out the distance here of this first ship. And right here, that's 6 degrees, and distance of the second ship. Okay. So how do you find that? Right, once again, we know that this right here is 90 degrees up here. So this angle must just be 90 degrees minus whatever the angle of depression is. Right, which is 85.5. Right, similarly, do this one. That's our right angle here of 6 degrees. So this is just 90 minus 6, which is 84 degrees. Okay. So from there, we have the angle, that's the opposite, that's the adjacent. So we just tangent that. So it's opposite over adjacent. So D1 is 100 times tangent of that. Right, do not round yet. Remember to round at the very end. So keep it as it is. Opposite over adjacent. Right, and then we just subtract the two distances. Right, so D1 minus D2. Right, so now we just do this in the calculator, subtract by this in the calculator. Which is this, rounded to the nearest tenth. Right, just like that. So you can see here, it's the exact same idea with the trig ratios. Right, it's just we are doing more steps. Okay, CN tower. Big tower in Toronto. Looks like this. Sure, why not? So it's this tall. An observer measures the angle of elevation to the top at 36 degrees, while another observer at the opposite side of the tower is 23.5. I'm looking for how far apart they are. Okay, so we got one observer measuring to the top. And then we got another guy and give elevation to the top. Not the most perfect straight lines, but that's okay. Right, so one of them is at 36 degrees angle of elevation. The other one is 23.5. Okay, I want to know how far apart they are. Right, so if we just find the distances, D1 and D2. We can just add them up to see how far apart they are. Right? In questions like this, don't worry about calculating the distance of the CN tower. Right? It's if I didn't say, it's like, oh, also make sure the CN tower is this wide. Right? You can just ignore it, the width of it. Okay. Well, here comes our two triangles. Right? The first observer, D1. Right, so that's this tall. Second one, that's D2. 23.5 degrees here. Okay, so in both scenarios, we're using sine here, right? That's the, oh, sorry, not sine, tangent again. That's the angle here, right? This is the opposite, that's the adjacent. Same here, that's the opposite, that's the adjacent. Okay, opposite over adjacent. This is the one with the extra steps. So D1 is 180.15.4 divided by tangent of 36. Okay, next one, the same idea, 23.5 instead. D2. Right, divide both sides by the tangent. And of course, you just add it up. Alright, so decimal calculator, add to decimal calculator. We got this. Right, just like that. Okay, next one. This one is a bit more difficult now. Right, so a ship sailed east for 40 kilometers. Alright, so we got our ship here. It sailed east for 40 kilometers. To avoid a storm, it changed course 50 degrees in a northeast direction. Okay, so what does that even mean? Alright, so think of, so we know the northeast, right, is that direction over there. Right, so it went this direction for 20 kilometers. Right, and it changed 50 degrees towards that direction. So we can imagine it. This is the north direction, changing 50 degrees northeast. This puts our angle right here. Right, so that's what that means. Okay, and lastly, how far is the ship from the original position? Right, so what's the distance from here to there? Right, so that's our distance here. Okay, so when we draw it out, right, let me scooch this up a little bit more. So then our triangle we're working with here, it looks like this. Right, so that's 90 degrees here. That's, oops, that's 50, 20 kilometers here, 40 kilometers here. We want to know what D is. Okay, so now what we can do here is we can actually just make a new triangle out of this, right? Because you can imagine if we have kind of extend out this little point here to make it into a triangle, right? This will make a right angle here. And now this D here, this distance, becomes our hypotenuse, right? If we extend this into this new triangle, right, if we extend this to a new triangle, this D here is the hypotenuse, right? Which means that we just have to find out what this new edge is, right? Let's just say that's B and that's A. Right? If we find out what this new little edge is, right? Those two edges, Right, then the base of this triangle is 40 plus a, and the second edge is b. We can just do, right, this added squared plus b squared equals to the c, the hypotenuse squared. Okay, so let's figure it out. Okay, so our new triangle here, it's now b tall, d as hypotenuse, the base or the other edge is 40 plus a. Okay, let's find out what b and a is. Okay, so as you can see here, if this angle here is 50, then this angle here is just 90 minus 50. So this angle here is 40. Okay, and from there we have everything we need, right? So from this angle, this 20 is the hypotenuse, b is the opposite, a is the adjacent. So let's look for b first. So sine of 40 is b over the hypotenuse. B is just this. Okay, a is same thing, except it's cosine. Adjacent over hypotenuse. A is then this. Okay, last step, Pythagoras theorem, right? We have this first side length plus the other side length equals to the hypotenuse squared. Right? So D is just square root of 40 plus this plus b squared. Okay, so we just plug everything into the calculator, right? It's gonna be a doozy here. Right, so the a goes in here, add that with 40, and then we square that. We add this squared, and then we square root the whole answer. We should get 55. Okay, so that's how I do questions like this. Again, very difficult extending stuff. Okay, so the next two here is also extending because it's more conceptual than just straight up calculations. Right, like I said, most of the difficulty of this unit comes from setting up the equation, not solving them themselves. Okay, so looking for a Ferris wheel here. Okay, so those are big circles. And then we got 16 passenger carts. Passenger carts. And the only number we're given here is the radius of the wheel is 10 meters. Right, how far apart are the carts? Right, and as the sin suggests, we don't actually need trig ratios at all. So let's draw this Ferris wheel. So look at this Ferris wheel here. Right? It's got 16 passenger cars, right? Which means that we can essentially split this circle into 16 parts. Yeah, that's good enough, right? Because each of those sections, you can think of it as little passenger carts. So ideally they are even. Alright, so those are 16 sections of those. Alright, so how far apart are each of those individual parts? Right, another hint is using the circumference. So circumference, or the parameter of a circle, is 2 times pi times the radius, 2 pi r. And we know this circle here, right, has a radius of 10 meters. Okay, so what do we do, right? So first, we can know the circumference of this entire Ferris wheel, which is just 2 pi times the radius, so it's 20 pi. Right? And we know that out of this whole circumference, it's divided into 16 sections. So what we can do is to divide this by 16. Right? And if we do that, we can find the length of each of those segments, right? Because it's divided into 16 sections. Right? So the distance here between those is just circumference divided by 16. So 20 pi divided by 16, which rounds to 3.9 meters. I said no trick needed, it's just conceptual stuff. Okay, here's a very difficult one. Again, conceptual stuff. Right, this one we'll need to use trig, but setting up is a hard part, right? So Mr. C is trying to put a strip of rubber around a small octagon table. Right, so if you remember, octagon is like a stop sign with 8 sides, right? Octagon, the octa means 8. Hence why we call it an octopus, because it's got 8 arms. Right, so, how to draw an octagon? This is gonna be like the most scuffed octagon you'll ever see. Okay, this one's kind of giving octagon. Yeah, I try my best. But let's go. That's okay. Right, so here's an octagon here. The distance of one vertex to the opposite vertex is 30 centimeters. Right, so it's pretty much saying the distance between those from one point to the other point. Right, that's 30 centimeters. Right, and now we're asking, okay, so how long should the length of the strip be? So in other words, I'm really just asking, what's the parameter of this octagon, right? The strip will go along this table. So if we just find the parameter of this octagon, then that's how long the rubber band strip is. Okay, so with our hint, let's divide it into 8 triangles first. If we do vertices, wow, this is not very octagon. In an ideal world, I'm perfect at drawing. Let's just pretend that they are all 8 equal triangles. Okay, again, this length here is 30 centimeters. Okay. So now what do? We want the parameter of the octagon. But we notice here that we can when we divide this into 8 triangles, if we just find the length of this part right here, then we can just multiply that by 8, and that's our parameter. Okay, that's our goal here. Okay, so let's try it out. Let's take a triangle out. Alright, and let's say this right here is our distance, right? If we can find what this distance is, then we can then we just multiply that distance by 8. Okay, so here's what else we know. From here to here, right? Because we know the whole thing is 30 long. So this distance here is just half of that. Right? Because as you can see here, if this is 30 long, then the edge length of this triangle must just be 15, right? There's something else we actually know as well, right? We actually also know what this angle is right here, right? This angle. This angle of all those triangles are going to be the same, right? And we know that because a circle here is 360 degrees, right? A circle 360 degrees. And there's 8 of those triangles where their tip gonna cross into the circle here. And if there are 8 even triangles, then we know that each of those triangles must just be 45 degrees. Or each of those angles must be 45 degrees. Right? Because again, a circle is 360 degrees. And we know that each of those triangles tips kind of touch the middle to form into this little circular shape, right? Into the circle angle of 360. So which means that each of those individual triangle angles must just be 1/8 of that, which is 45 degrees. Okay, so we're almost done. How are we supposed to find the distance here, right? There's no right angles here, right? We do not have any right angles that we can use trig ratios of. So what we can do is just split it up. Right? We can now split this triangle further. Because again, we can't really do anything without right angles. So what we're gonna do here, if we split this triangle down the middle, and voila, we just created a right angle. Right, once again, all those are the same. Okay, if we just split it down the middle, we actually notice something else here, right? If we can find out what the distance here of this little strip is, we can multiply it by 2 to find out what this distance is right here, right? So, let's say this is D1 here, right? Because then if we double this distance, of D1, we get this distance here. And then we can multiply this distance by 8 to find the whole parameter. Okay, so we have almost everything we need. Right, we have one hypotenuse, and then we have one side on the side of 12. So we need an angle now. Luckily, we do have an angle. If we were to split this down the middle, this angle here, then must be just 45 degrees split into 2. Alright, and then we have every single piece of information that we need. For this angle, that's the opposite, that's the hypotenuse. Right, we have that. So we have opposite sine is the small distance over 15. 15 here is the hypotenuse. Right, okay, let's not jump the gun here. Alright, so this small distance here is 15 times sine 22.5. Then the big distance, then this d here is 2 times that. So it's 30 times sine 90.5. And so the total parameter now is just 8 times this, right? One segment of D is this, so we want 8 of that to find the whole parameter. So 8D is just 240 times sine of 22.5. Right? And from that, plug that into a calculator. 91.8 centimeters. Okay, just like that. Right, so as you can see here, there's a lot more steps for this question, right? But the core idea is the same, right? We just want to figure out where a right triangle is. Okay, so that being said, just like last time, get used to the simpler ones first, right? And then from there, try out the harder ones by yourself. Right? Again, if you're ever stuck, try to just find a right triangle out of something. Right? Same idea as here, right? There's no right triangle in this question, but we can just make one here. Right? So always try your best to try to figure out a right triangle out of something. Okay, so with that being said, good practicing.